Today we're going to cover targets 3 through 5, which sounds like a little bit of a lot, but it actually all goes together really nicely. Um, so I'm going to talk about a few things that are written here, but ultimately as I go through examples, I'm going to hit all of these points that you see at the top of your notes. What we're going to do is graphing rational functions. And so you guys know what rational functions look like right now. And so we are just going to graph them. And so there's two really important parts of a rational function, and that would be your asymptotes. There's two asymptotes like we've talked about. Okay, so in the denominator, this actually represents your vertical asymptote. Whatever is going to make your denominator equal to 0, because you can't divide by 0, so we have to have an asymptote there. The number at the end is going to be your horizontal asymptote. Now this is actually a little bit different than what you would think, because if you notice where I just said you have a vertical asymptote in blue, it actually has the letter H. And where I said you have a horizontal asymptote, it actually has the letter V. So I'm going to draw a line here. Let's start with a vertical line. Okay, so just taking a look at that vertical line. If I move the vertical line up or down, it actually doesn't move the location of the line. It's still in the same area. But the vertical asymptote, or the vertical line, is going to be affected by the horizontal shift. So what I have written in the blue is, yes, the denominator does represent your horizontal shift, but ultimately that means it's the vertical asymptote, because the vertical asymptote, is the one that's affected by the horizontal shift, shifting to the left and right. And so the opposite's going to be true for a horizontal asymptote. So if you think about moving a horizontal line left and right, it actually doesn't move like the location. It stays where it is. So in red, I said that V is the horizontal asymptote, and that's because the vertical shift, moving a horizontal line up and down, actually is what creates that movement. And so that's what we have here. And then we're going to talk a little bit about domain and range as well. So basing what we had up above, the denominator tells you what your vertical asymptote is. So what would make the denominator equal to 0? 0 would. So your vertical asymptote is going to be x equals 0. It's always x equals because it has to be the equation of a vertical line. Then if you had a number behind, which we don't, so I'm going to put a plus 0, that would be your horizontal asymptote. So the horizontal asymptote is y equals 0. Now these are going to correlate with domain and range. So notice that the vertical asymptote is written as x equals. Remember that your domain goes with x as well. So your domain is going to be all real numbers except where x is equal to 0. And that's how we're going to write that. So it's all real numbers except wherever your vertical asymptote is. And then your range is going to be all real numbers except where your horizontal asymptote is, since that's y equals. So again, domain goes with x, that's why it goes with the vertical asymptote. Range goes with y, that's why it goes with the horizontal asymptote. So same idea, and we're just practicing. So this is target 3, just kind of getting used to the idea of a horizontal and vertical asymptote, where we find that information. So in our denominator, it's going to be whatever makes x equal to 0. So your denominator is going to equal 0 when x is 2. So your vertical asymptote is going to be x equals 2. So then right off the bat, you could actually go ahead and do your domain as well. So if you know your vertical asymptote, then you know the domain is going to be all real numbers except x can't equal 2. All right. So then your horizontal asymptote is right here. So it's y equals 1. And then remember that goes with your range. So the range is all real numbers. Y is not equal to 1. Again, we're just talking about some basic information here. We're going to actually apply that to the graph and move on to target 4. on your next page. So go ahead and flip with me and we're going to continue that same pattern to start off with. So remember, your vertical asymptote comes from the denominator. What would make the denominator equal to 0? Negative 3 would. So x equals negative 3. So your domain is all real numbers. X can equal negative 3. So now we're going to take this to the graph, and I'm going to actually plot the vertical line at negative 3. I'm going to make it a dotted line because an asymptote is a line that an invisible line that your graph gets really close to but never crosses or touches. So just kind of mimicking that invisibleness with a dotted line. And then the number back here, that's going to be your horizontal asymptote, so y equals negative 5. So it's all real numbers. Y is not equal to negative 5 for your range. And again, I'm going to put that on the graph. Okay, so the asymptotes, once they're on the graph, then that's kind of like the bones of your graph. And then from here, we just have to add a few extra points. So we're going to create a table. I'm going to be doing some scrolling up and down. And what we're going to do with our table is we're going to pick two numbers to the left of your vertical asymptote and two numbers to the right. So your vertical asymptote is at negative 3. So two numbers to the left would be negative 4 and negative 5. I'm just picking some x values here. And then again, your vertical asymptote's at negative 3, so two numbers to the right would be negative 2 and negative 1. Now to get these points, I'm going to take these x values that I picked from the graph, and I'm going to plug them into our equation. So when I plug this in, I'm going to actually write out how I'm going to plug in the first one because you do have to be careful with parentheses here. So if I'm going to replace x with a negative 4, I'm going to do 2 divided by, and then I'm going to open a parenthesis, and I'm going to plug in that negative 4, and then it's plus 3, so the denominator should be in parentheses whenever you type this in. And then I'm going to put that minus 5 at the end. So that's exactly how it looks in my calculator, and I'm getting out a negative 7. Now that I have that set up in my calculator, I can just change that number. I'm going to change the negative 4 to a negative 5. And now I'm going to change it to a negative 2. And now a negative 1. And then I'm going to plot these 4 points. So I have negative 4, negative 7. And then I have negative 5, negative 6. Negative 2, negative 3. And negative 1, negative 4. Okay, so it doesn't seem like we have a whole lot of information in terms of the shape of the graph. However, you guys know what a rational function looks like now that you've done targets 1 and 2. So you know that your graphs curve really close to the asymptotes. We can't cross or touch those asymptotes, so it's those two ramp-looking shapes, and they have to go through those points. So those are the steps that we would take in order to graph a rational function. So we're just going to practice that a few more times. So starting with the vertical and horizontal asymptotes. So just a reminder, vertical asymptote comes from the denominator. What would make it 0? That would be positive 2. So your domain is everything but that, since that graph can't go to 2. I'm going to go ahead and graph that as well. So vertical line at 2. And now we're going to look at the horizontal asymptote, which would be that number at the end. So notice I'm ignoring sort of that number in the numerator. That doesn't affect any of the asymptotes. So the horizontal asymptote is at y equals 1, so the range is everything but 1. Okay, so before I scroll back up to try to minimize some of the scrolling, let's think about our table of values, and so some numbers that would be to the left and the right of the vertical asymptote, which is the blue one. So that's at 2. So two numbers to the left would be 1 and 0. Two numbers to the right would be 3 and 4. So I'm going to use 1, 0, 3, and 4. So remember, we're going to plug that back into the original equation. I'm going to use the same format that I used on the last problem to make sure that I get the right output. So I have -1 divided by, and then in parentheses, 1 minus 2, close the parentheses, add 1, and I get out 2. And now I'm just going to go through and replace that 1 with a 0, and then a 3. Decimals are okay to get here, so if you ever get decimals like I'm getting, don't worry. Okay, so 1, 2, 0, 1.5, 1, 2, 0, 1.5, and then we had 3, 0, and 4.5. Okay, so again, it follows that same shape, so we're getting really close to the asymptotes going through the points, but never crossing or touching the asymptotes. Okay. 2 more examples, so just going through those same steps. Your vertical asymptote is found from your denominator, so what would make the denominator 0? That would be +1. So your domain is all real numbers except +1. And I'll go ahead and graph that. You really do have to put the asymptotes on the graph first, that way your XY chart is accurate and you've picked good numbers for the X values. And then the horizontal asymptote is this last number, so it's Y equals 3. So your range is all real numbers except Y can't equal 3, so I'm going to put that on the graph. All right, so now a table of values. So for the table of values, 2 numbers to the left and right of the blue line. So the blue line's at 1, so 2 numbers to the left would be 0, -1. 2 numbers to the right would be 2 and 3. So 0, -1, 2, and 3. Okay, so I'm going to go back to our original problem and start off by plugging in a 0 for x. I'm going to get my calculator set up. So I get out -1. If you're having trouble plugging this into your calculator, just talk to your teacher about that. They can help you out by looking at what you're plugging in and maybe trying to fix that for you. All right, so I have my 4 points, and now I'm going to plot them. So 0, -1, and that was -1, 1, I believe. Yep. 2, 7, and 3, 5. Okay, so it's the same shape. Points are a little bit more spread out this time, and that's okay. But notice that all of these graphs are ending up looking the same. They have those 2 curved parts to them that aren't connected. Okay, so last one running through, how do we graph? So your denominator gives you your vertical asymptote, so that would be x equals -4. -4 would make the denominator 0. So your range is all real numbers except -4. I'm going to go ahead and plot that. And then your horizontal asymptote is this +4 at the end. Make sure you always do x equals and y equals for those, don't just put the number. And following our pattern, our range will be all real numbers except for 4. So after I put the asymptotes on the graph, then I'm going to make a table, and the table It's going to be determined with some x values based on the blue line, the vertical asymptote. So two numbers to the left would be -5 and -6. Two numbers to the right would be -3 and -2. -5, -6, -3, -2. I'm going to scroll back up so I can see the equation so I can plug those numbers in. All right, so for -5, I'm getting an output of 7. For -6, I'm getting 5.5. For -3, I'm getting 1. And -2, I'm getting 2.5. All right, so starting with -5, 7. And then -6, 5.5. And then -3, 1. And -2, 2.5. And again, these graphs all have similar shapes, so we should know how to connect those points from there. If you wanted to plug in more points, you absolutely could, but you only need 2 to the left and 2 to the right. So that's graphing a rational function. And then what we're going to take a look at is target 5, which is actually a matching target. So now I'm giving you equations of equations of rational functions and then graphs, and then we have to determine what goes where. So what I like to start with here is I actually like to start with the vertical asymptote. You can start lots of places. So I'm going to go through and write what the vertical asymptote is next to each of these. So remember, that's according to the denominator. It's the opposite sign of the denominator. And what I'm noticing is that some of these equations have a unique vertical asymptote, meaning no other graph or equation has that same vertical asymptote. So we have 3 of them that have x equals 0, but everything else has a unique asymptote. So I'm going to start with number 2. Number 2, the vertical asymptote is -5. So I'm going to see if I can spot where a vertical asymptote of -5 is. Right here on D, I can see that that vertical asymptote's at -5. So number 2 goes with D. And you can match this either way if you want to do numbers to letters or letters to numbers. Number 3 is the only one that has a vertical asymptote at 2. So again, I'm going to go through and see if I can see a vertical asymptote of +2. And this one on F. I can see that vertical asymptote is at +2. So number 3 goes with F. I'm skipping 4 because that has a vertical asymptote of 0, like a couple other of them do. And then on number 5, it has x equals -8. So I can see that vertical asymptote here for A, so 5 goes with A. 6 has a vertical asymptote at 6, which looks like that matches with E. And then 8 has a vertical asymptote at 1, which is here at B. Okay, so I've matched most of them, and I could actually eliminate what I've matched. So I've matched A, B, anything that I've written on, D, E, F, and then I have the 2 at the bottom. So I have G, H, and C left. So let's take a look at the 3 equations that remain. Of those 3 equations, the only one that has a different horizontal asymptote is 7. And 7 has a horizontal asymptote of -7. So of the 3 that are remaining, I'm going to look at which one has a horizontal asymptote at -7. So that looks like that would be G. Now the 2 remaining graphs, there's a few things you can do. What I think would be easiest is notice that number 1, that numerator is positive, and on 4, it's negative. So if you look at graph C, which we still have left, excuse me, if you think about the two quadrants that graph is in, that has a positive linear correlation, so it's going upwards. So that's going to go with the positive graph, which is number 1. On the graph that we have left, it's going downhill, so it's going to go with a negative numerator, so H is going to go with 4 that had a negative in the numerator. So you can use lots of different characteristics of the graph in order to match them, but that was just a couple methods that I use. And that's your notes over targets 3 through 5.